forward. So we're doing a quick review of Schoology, and then we're going to get into today's notes. So Schoology, this is E period. So we're in our E period class. You guys all found the Zoom link, so I think that's pretty self-explanatory. However, I will put it in the links folder soon, this green folder called links. That's just where all my other URLs are. So I think that's easier to keep it all in one place. And then it cleans up that main screen a little bit. You'll see that there's a second Zoom link here, and it's for anytime you need help outside of class. So before school, during flex, during resource, right after school, in the evenings, if you ever need help from me and want to Zoom, we're gonna use this link. However, it's not like a phone call, so you can't just press it and expect me to like answer every time. You got to give me a heads up. So if you want to do that, that's totally cool, but you need to give me like a little email heads up so I know to like look for you or I'm ready to help you. I also have my YouTube link up here. So I started when we started having COVID stuff and being online, I started making YouTube videos of my lessons. And so every class I record one class. And so today it's you guys. And then I make a video of it and I label it like geometry and then whatever lesson it is. So you can scroll through all my videos. If you're looking for something specific, I did put it in playlists. I'm not very good at YouTube, but I do know that if you put it in a playlist, then all of those types of videos are together. So like we're in unit 5 in geometry. So like after today's class is over, I'll put this video in that YouTube space. And it will always be labeled geometry and then whatever lesson it is. And you can see all my past stuff here. If you're just like ever curious, you probably don't need to watch it because we've kind of closed the chapter on semester 1 and everything now on is new stuff that you're responsible for until the end of the year. I didn't get a lot of feedback from you guys because we finished the semester online and not in person, but the small amount of feedback I did get was that YouTube was really helpful. So whether you're absent or sick or just not mentally here when we learn a lesson or you need to see it again or whatever reason, you can always go look at that. Any answer keys will be in this yellow folder, but we don't have any yet, so that's empty. And then everything else is under organized by weeks. I have assignments here, and so I did just assign a homework today. So I see you again on Friday. So the homework that I assigned today will be due on Friday. And then all of your materials are in weeks. If you don't know what week we're in, hi Jess. If you don't know what week we're in, it's by date. And then each folder in there tells you which day of the week it is. So like today is Wednesday, so I know that we're gonna do the lesson and then the homework. I also put a schedule for the week up so you can know what to expect. So if you're like, okay, I know on Friday I have to leave early for an appointment and I'm going to miss math class, you can see exactly what you would be missing and then you can be on top of your work. So I think that gives you guys some autonomy for yourself and then some responsibility, and it helps just build some mature habits. So that's that. We are going to do this first lesson. So I'm going to download this. And I know you're probably like, Miss White, this is so elementary. We know how to download things from Schoology to Notability. But what I do want to point out is when you make a new note, and I don't know if this is new or if this is old and I'm just now noticing it, is this note title is like a whole bunch of nonsense. Like there's no way I'd know what I was looking at from this. So I highly suggest renaming all of your things from Schoology if you have any hopes of finding anything in the future. So like if maybe you'll call it geometry notes and then today's date, or maybe you have a folder called geometry, so you'll call this like lesson, and this was called special segments, and it's chapter 5 stuff. Whatever you want to call it, just call it something different than that nonsense it was labeled, okay? Or else it's going to be a whole pain in your butt later to figure out where things are. Okay, I already downloaded it, so I'm going to go to that now. It's a 2-page note, so it should go pretty quick. We have gone pretty much to the end of class today, so 2:55. I know that that's when we end, so I'll do my best to stay on top of it. And then for those of you who are new to class or for those of you who just want a reminder, I will ask for help, and it's easier if more of us help than just sit there in silence, or I'm gonna have to call on you. In the past, especially E period, you guys have done an awesome job of participating. The only thing I ask is that like you answer one and then you like let a few more people answer. I'll tell you if it's open to everybody again, or if I want somebody new that I haven't talked to. So I don't want to just only talk to one person all class. I want to hear from everybody. And this is a big class, so I want to hear from as many of you as possible. I am gonna need help at the very beginning because this is a review, but then I'm gonna do a lot of just kind of new material to begin with in the middle. And then when we hit the second page, I'm gonna need more help. So just, I like to give you a heads up on when I'm gonna have questions and when I'm not necessarily. So any questions so far? Okay. I'm gonna get started then. We are in special segments in triangles, chapter 5. So I took a bunch of concepts from all of chapter 5 and just smushed them down to one lesson. And I'm actually going to need help because we should know this first special segment. It's called a mid segment. Mid segments are made up of what? What are the end points of mid segments? What are they called? When I draw a mid segment, what are the end points of that mid segment?
They are the midpoints in the triangle.
They are the midpoints of the sides of the triangle. Very good, Ava. So mid segments are made up of midpoints. So I'm going to go over here and I'm going to draw them. We're not perfect. We're just people. We're not machines. So I know that you may not draw a perfect midpoint, but I want you to try your best. So that to me looks good enough. That looks like it's about in the middle. I am going to use little congruent marks to show that I think it's in the middle and to show that I think it's the midpoint. Same thing over here. I think like this is about the midpoint. So those segments look about congruent. And then I'm going to connect them. You can draw just one, but technically there are 3 midpoints because there are there are 3 mid segments because there are 3 midpoints of the 3 sides in this triangle. So I can also draw this last one, 1, 2, 3, 1, 2, 3, and make a second mid segment and make a third mid segment. So all triangles have 3 total mid segments, but I'm going to focus on this one for my last 2 kind of fill in the blanks, and then the side opposite it. Okay, so Ava told me that mid segments were made up of midpoints. And then last year, we also learned a mid-segment theorem that told me 2 other pieces of information about these mid segments. One of them says mid segments are blank to the sides of the triangle that it doesn't intersect. How does the mid segment as a line and its side opposite it relate to each other?
Parallel.
Parallel. Very good, Ava. Parallel. All right, we got another concept. It says the length of a mid segment is blank as long as the side that it doesn't intersect. What do we know about the lengths of the mid segment compared to the side opposite it?
It's half.
It's half. All right, Ava killed that question. So at least Ava knows what happened last quarter. We've got parallel, parallel, and I'm going to call this total segment at the bottom 2x. And so half of that would be x up here. Any questions so far? All right, the next 2 segments I think you might know, but let's talk about them all together. The last 2 I don't think you have any idea of. So the first 2, let's try these. We should know some of these base words. So first one is angle bisector. We know a bisector is something that cuts another object into 2 congruent parts or 2 congruent pieces. The word angle in front means that we're cutting an angle into 2 congruent parts or pieces. A bisector is always a line or array or segment, so you need 2 points to name a angle bisector or a segment bisector or anything along those lines because it's a line or array or segment. And it divides it into 2 congruent angles. So when I draw a bisector for angle A, I have to go through the vertex of angle A. Remember, vertex is like the point that like the angle is actually happening at. And I'm going to cut that big angle A into 2 smaller angles. Now, I love drawing this on Notability because I can erase really easily. If I drew this, these are not congruent angles. I've got like a tiny angle right there, and then I've got a giant angle over here. So those are not congruent. That does not work. Same thing if I like cheated it over here, that also is like a tiny angle and then a giant angle. So that also doesn't work. We will not be perfect, but I am going to try and make this as good as possible where the angles look like they're about equal. That's equal to that angle. And that's all I technically know. All I know is that I went through the vertex and I've got these 2 congruent angles. One thing I'm going to do before I move on is I'm going to write something off on the side. And I'm going to do this for the first one. I forgot to do this earlier. A midsegment is made up of two midpoints. So in the margin, I'm going to write two midpoints. An angle bisector goes through the vertex of angle A and it makes two congruent angles. So I'm going to write that. I'm going to write vertex and I'm going to write congruent angles. It seems silly right now, but I promise in a few minutes it's going to make sense why I'm putting these little words off to the side. Okay. The next question says, does an angle bisector of a triangle have to bisect the opposite side? I know this point right here looks like it might cut BC in equal pieces, but that distance and that distance are definitely not the same. The distance between B and that point is a lot smaller than the distance from C to that point. So this is not a midpoint. And I might even write that on here, not a midpoint. I might even write that on here because an angle bisector does not have to bisect the opposite side of the triangle. It does not. I'm going to write no for that. Any questions so far? Time to switch from coffee to water. I got to get hydrated. Oh, okay. Next one is perpendicular bisector. Well, we just talked about bisector, so it's a lot of the same idea as before, but this one is not an angle. This time we're talking about a side. Again, I'm going to remind myself that bisector means cuts into two congruent parts. And the perpendicular means that it makes a 90-degree angle when it does that. The bisector is an object. It's a line or a ray or a segment that's perpendicular to a triangle side at its midpoint. So midpoint is important. All I care about here is a line that goes through one of the sides and that's perpendicular to it. Perpendicular bisector of AC. I'm going to first draw the midpoint of AC. So the point right in between A and C, we're going to call that the midpoint. And then I'm going to draw a line between that this new line will be a 90-degree angle to AC. A common mistake we do is we make it perpendicular to the side opposite it. You're like, okay, here's my perpendicular bisector. No, 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 I don't want it perpendicular to that side. I want it perpendicular to the side that it's going through. So it's going through AC, so I want that to be the perpendicular angle. You may need to physically like move your iPad around, or like when I have paper, I physically move it around so I can see what the best 90-degree angle is. I think this is about 90 degrees. Again, we're not perfect, so try your best. Like I might be a little bit off, but I'm close enough, and I'm going to show that I know that it should be a 90-degree angle with my right angle. The two special things about this are the midpoint we drew, and then the right angle, which we just drew. So I'm going to write that off to the side. Midpoint and then right angle. It says, does a perpendicular bisector of a triangle have to go through the vertex? I'm going to answer that one for us. That's a vertex, that's a vertex, that's a vertex. This purple line is nowhere near any of those points, so no. I never say never because sometimes it happens if it's a special triangle, sometimes it goes through the vertex, but it does not have to. By definition, it does not have to go through the vertex. So instead, I'm going to write no because it does not have to. That's not a property or like a special thing about this. Okay, I've done 3 so far. Does anyone have any questions? Everybody with me? Okay, I don't need help yet. I still feel like I'm yelling into the abyss, so just speak up if you need anything. These next 2 words I think are new. I don't think we've seen them before. We have median and we have altitude. So median is a segment that has endpoints of a vertex of the triangle and at the midpoint of the opposite side. So what's important is a vertex and midpoint. So I'm going to draw a median to AB. So I'm going to go find the midpoint of AB. That's about there. And I'm going to connect that to the vertex. It's not a vertex next to it. Like that's just half of the side. That doesn't mean anything. A median goes to the opposite vertex. So vertex and then midpoint. There's no right angles. There's not necessarily any congruent angles. That's not true. There's no perpendicular, nothing. All I know here is a vertex and midpoint. Okay, we've got one more. Oh, the way I remember median is most of you either have a license, have a permit, are thinking about driving, something along those lines. So driving is super relevant to us. Median is what we call that space in the road, like on an interstate. If you're like out in the country, it's like that kind of like grass that's between like the two ways of traffic that we call the median. Or if you're like in the city, like when I drive, like when Binford turns into the interstate 69, I think, they have like that small little concrete wall. That's the median between the two ways of traffic. So median to me, I can remember median's in the middle, and the middle is a midpoint. So if that helps your brain at all, you can use that. The last word is a word that I think you've heard before, but maybe not in math. It's called altitude. Another way we've described it is the height. So the altitude of the triangle and the height mean the same thing. When you were in middle school math, you would take the height of the triangle to help you find the area. If you've ever been in an airplane, they get on the announcements and they're like, this is your captain speaking. We are currently cruising at an altitude of this many feet. The altitude is the distance from the plane straight down to the ground, not at an angle, at literally a perpendicular, a right angle from the plane down. And that's exactly what an altitude is here. It's from a vertex straight down to the other side. If I'm going to do an altitude to BC, I'm going to go through the vertex across from BC, which is A, and then I'm going to draw a line that makes a 90-degree angle. So again, I like doing this on Notability because I can easily erase. If I draw this, this is not a 90-degree angle, so that doesn't count. Same thing if I brought it a little bit over here. That's also not a 90-degree angle. I'm going to try and do as much right down the middle as possible. Right about there seems good. That seems as close to 90 degrees as I can make it. Another thing here is I don't necessarily have a midpoint. The distance from B to the middle is shorter than the distance from the other side to C. It could be a midpoint, but it does not have to be a midpoint. The only things I do know is that it's a right angle and it's a vertex. So those are the two keywords I'm going to write over here. Vertex and right angle. Okay. Anybody have any questions? Everybody have all your words off to the side like I do. That's going to be super helpful in a minute. What we're going to do is I'm going to do a couple examples first just to kind of ease us in. I've got 10 triangles with segments, and we're going to identify which special segment we have. The reason I wrote these words off to the side is we're going to use them to help us identify which one is there. So like if we have a median, for example, we should see both the segment go through the vertex and go through the midpoint. If we have like an angle bisector, it should go through the vertex and we should have congruent angles. Okay, I'm going to do, let's try 2, and then I'm going to need some help. So that would give me like 8 people that are going to need to help me in a second. I might be scrolling back and forth, so if that makes you dizzy, I'm so sorry. In this first picture I have, so I'm in the first triangle on the top. It looks like I have a right angle, and then it also looks like angle A is a midpoint because I've got these 2 congruent marks here. You don't have to write this, but I think it's helpful sometimes. I have a midpoint and I have right angles. Now I'm going to go back above and I'm going to figure out which one also has midpoint and right angles. Not altitude, not median. Oh, it is a perpendicular bisector. Instead of reading through the entire page of notes, I've got my little cheat sheet off to the side. And so since I've got a right angle and a midpoint, I've got my perpendicular bisector. I don't know who just joined us. Whatever. All right, perpendicular bisector. Okay. Any questions so far? All right, let's.
Miss, I'm sorry that I joined late.
Who is that?
This is Jacob, Miss.
Hi, Jacob. I don't know if you're in my class. What's your?
I think I have you for 4th period. What period is this?
We're in E, the fifth block.
Oh,
What?
this is, sorry, Miss. I think this is the wrong class, I think.
Okay. Bye.
Okay, Miss, you have a wonderful day, gorgeous.
Bye, Josh.
What was that?
I don't know. I just removed him. Well, that's fun. That's on our nice little video that you can watch on YouTube later. I'm going to report that as an uninvited guest. Oh, shoot. I think I said don't report. Ugh. You know, I almost didn't add them because I didn't know who it was, but I was worried it was someone in our class. Oops. Okay, my bad, guys. Okay. Where was I at? Number 2? Perpendicular bisector. Is that where I was at?
Yeah.
All right. I feel very distracted. Okay. All right, focus up. We got less than 20 minutes. On this one, I have a angle bisector, or sorry, I have 2 angles that are congruent, and I have a vertex. I jumped the gun. Sorry, my brain's not here yet, now that I got distracted. Vertex and angle congruence. What I meant to do is lead us to the fact that since we have congruent angles and a vertex, we have what we call an angle bisector. So angle bisector. All right, since we got rudely interrupted, I'm going to do one more, and this is going to be my verbal warning that if you try and join without your name, I'm not going to add you. So most of you, that's not a problem, but I had somebody else add in as just iPhone this morning and I let them in and it was one of my students. So because we were just Zoom bombed, that's never happened to me. I need you to always log in with your name or else you'll be removed and not added into class. So sorry, that's where my brain's at. So that's just what we're doing from now on. Let's do one more example. On this one, I have points A and B and my segment is in between them. And it looks like I've got congruent marks. So that means A is a midpoint. And then I've got congruent marks at B, which means I have 2 midpoints. And let's go figure out which one has 2 midpoints. It's a midsegment. So I'm going to do midsegment. As my answer for number 3. Okay, I know we got rudely interrupted, but does anyone have any questions or any thoughts or comments or anything right now? Do you think you guys can help me for the next, I don't know, what is that, 7? Even if you're not quite sure, I want help just identifying what we see and then we can figure out what the special segment is. So who can help me on number 4?
I can.
Okay, Ava, what is number 4?
So there's a midpoint because you can see the congruent marks.
Good.
And then there's also a vertex.
Awesome.
So that would be a median.
Very good. So vertex and midpoint mean median. Awesome. Thank you, Ava. All right, somebody else. What do we have on this next one?
I can do it.
Awesome, Maggie.
There's a right angle and a midpoint, so it's a perpendicular bisector.
Oh, it does look like a midpoint, but is it marked as a midpoint?
Oh, no.
No. So even though I want it to be marked, since it's not, we don't get to do that. Honestly, the only thing I see right here is a right angle. Is that enough information? Is that enough information for me to know that it's like a mid-segment or anything else?
Miss White, would it be an altitude?
So altitude does have a right angle. That's a good guess. The one thing I do see, Abby, though, is it doesn't go through like the vertex up here. So it would have to go through that in order to be a altitude. And then again, we don't necessarily have a midpoint. This one's kind of tricky. I love that you guys all are volunteering to help, but this one's actually a none. I know you're probably like, oh, Ms. White, I hate when you put nuns on here. Nuns happen sometimes. We need two pieces of information and we only have a right angle. So that's all that we have to go off of. And that's not enough. So that's a none. All right, let's do another one. What about this? Even if you help me on that last one, you can help me on this one, because that one was kind of weird. What do we have here?
This one has a vertex and a right angle. So
Good.
this one would be altitude.
This one is altitude. Very good, Silas. This one has a vertex and a right angle, and so we call that altitude. Very good. What about the next one? What's going on here? What do we see here?
There's a midpoint and a right angle.
And what do we call that?
That's a perpendicular bisector.
Good. Good. All right. Any questions on the first four that we've done all together? All right. Somebody new I haven't talked to yet. What about this one? What do we have here?
Doesn't that have a vertex and a midpoint?
It does.
So it'd be a median.
Very good, Amanda. This one is a median. Midpoint and vertex mean median. Awesome. Okay, we got two more. What about the fourth one? Who is new and who can help me on this one? Who have I not talked to?
Would it be mid segment?
It would be, Charlie. Why is it mid-segment?
It has two midpoints.
Very good. A and B are both midpoints because they've got the little congruent marks on them. And so that makes two midpoints connected, makes a mid-segment. Very good, Charlie. All right, and this last one's a little tricky. Who else have I not talked to who can help me on this one? What do we see here? Hello, who can help me that I haven't talked to?
Is it altitude?
It is altitude. Why is it altitude?
Because there's a right angle and
And a vertex.
and a vertex.
Yeah, very good. Thank you, Elise. And then I don't know who chimed in there at the end, but yeah, it's an altitude. This one is weird and maybe looks a little bit more confusing because I've got this little like dotted line situation over here. Altitudes have to go through the vertex and then they have to make a right angle. Sometimes that doesn't happen inside the triangle. Sometimes it happens outside the triangle. So I'm gonna write sometimes, not always. It sometimes happens outside the triangle. So if you ever see a dotted line, it can be a altitude. Charlie, do you have a question?
No, I didn't mean to press that.
Oh, that's okay.
Sorry.
I don't know if here, I'll lower your hand for you. I just thought you were actually using it. So perfect. Okay, any questions on these first few? Okay, we got about 10 more minutes and we've got this last box to fill in. So this is a picture. You may see a picture like this or a diagram similar to this on your homework or on a quiz. So we're gonna zoom in and we're gonna just look right here and we're gonna focus on the first three, which deal with this big triangle, DEF. DEF, median, altitude, and angle bisector. Who can find one of those? Who can find median, altitude, or angle bisector? Floor is open to anybody.
Would a median be LD?
A median would be LD. Very good, Charlie. And what's special about a median?
It has a vertex and a midpoint.
Very good. And LD is a midpoint and a vertex. Very good, Charlie. Who can give me either altitude or angle bisector of this orange triangle?
Would an altitude be FK?
It would be. Why?
Because F is the vertex and K it forms a right angle.
Very good, Ava. K is a right angle and F is my vertex. So that is FK. Very good. What about, that leaves the angle bisector? Who else?
Would the angle bisector be angle E?
Angle E is the one bisected. You got to give me 2 letters though. So what is that other letter that bisects it?
G.
G. Very good, Abby. EG is my angle bisector. I love how you knew that angle E was where the bisecting happened. Just remember that we're doing special segments and segments are always 2 letters. Awesome, good job. Okay, so that was all DEF. Now we're going to look at 2 other triangles. So we've got EHF and we're gonna do the median there. And then we're gonna do the altitude of HEK. So let's do the median first. So I'm looking at EHF, which is right here. We need a median. Who can find a median for me?
Would it be line HL?
It would be HL. Why?
Because it looks like it's dividing it fully in the middle, but not fully. That's a weird way to explain it, but
What makes up a median? What are the 2 special points of a median?
it has a vertex and a midpoint.
Very good. Vertex and a midpoint. H is the vertex. L is the midpoint. Very good, Abby. What did we just say? HL. All right, and then now we're looking at a new triangle, HEK, which is this one right here. I also, my biggest suggestion is don't be like embarrassed to draw on your picture or to write stuff. Even when we do paper pencil, lightly shade something in and then erase it. I don't want you to get confused because you're too cool for school to write on your paper. Sometimes you guys give me crazy answers because you just like didn't take a minute to like actually look at what you're doing. Okay, we're looking at altitude in this triangle, HEK, this little like orange triangle I have here. And I actually see 2. Who can give me 1? What's one altitude?
Is KH one of them?
KH is 1. Why, Ava?
Because there's a right angle and a vertex.
Good, a right angle and a vertex. That's all that makes up an altitude. KH. And then can somebody new give me the other one? What's the other altitude?
KE.
KE, very good. Silas, same concept. Now, the reason I did this one and I told you there were 2 is because in right triangles, 2 of the sides are actually altitudes. So I'm gonna write KE down and then I'm gonna write a little note that says in a right triangle, 2 sides are altitudes. Two sides are altitudes. And there's actually, I'm gonna cross off this last one. I have 4 spaces, there's only 3. We're just gonna do 1 for sake of time. I want us to find another right triangle in this picture and I want us to name the 2 altitudes that go with it. So we were just looking at HKE or HEK, whatever you wanna call it. Can someone find another right triangle in this picture? Someone find me a new right triangle in this picture? I haven't heard.
HLE.
Oh, go ahead. What did you say, Charlie?
HLE.
HLE. Are there right angles on that?
I guess not.
We don't know unless it's marked. So we got to do one that's marked.
JDK.
JDK. Oh yeah, that little tiny one. Oh, sorry. What were you saying?
So would you list all 3 of those angles or would you just list a segment?
I want all three angles to look at one triangle right now, and then we'll list segments after that. So Silas, did you
Okay.
say JDK right here?
Sorry, what's up?
Did you say JDK? Did you say this triangle right here?
Yes.
Yes, okay. If you didn't, I heard it from somebody else and that works. You also could have done FDK, like the big little skinny right triangle there, but we can also look at this little guy right here. So J, D, and K, this is my triangle. Now I need segments that are the altitudes, and I think there are two. What are my two segments that are altitudes here?
DK and JK.
DK and JK, yes. Now I keep hearing people leave, and I know I'm speaking to the choir because you guys are here, but like class isn't over yet. So not really sure why people keep leaving. And this was in triangle JKD. Okay, I have two more questions for you about this whole figure. It says, are there any perpendicular bisectors shown? Are there any perpendicular bisectors shown? Anyone see any perpendicular bisectors?
F and K.
F and K, that's perpendicular, but is it a bisector?
No, it's not. Never mind.
It's not. What does it need to, what did it need to be if it was a bisector?
For it to be a perpendicular bisector or just a bisector?
A perpendicular bisector.
A midpoint and a right angle.
A midpoint and a right angle. And I don't have that. I just have a right angle. I don't have a midpoint. And so I don't see any at all there. Good. I like how you add that clarifying question about that because there are none. Now there are normal bisectors. A normal bisector is just something that intersects a segment at its midpoint. Does anyone see any normal segment bisectors?
EG is one.
EG, oh, do we know that? Is that a segment bisector?
Oh, no, it's an angle bisector. My bad.
What's a segment bisector? Where do we have a midpoint at?
L is a midpoint.
L is a midpoint. So what's a like a segment that goes through L?
DL.
DL works. And then the other one I was thinking of is HL. I know we're almost done. Give me one more second, guys. So DL and HL are my segment bisectors. Those are not perpendicular bisectors because they are not right angles, but they are bisectors because they go through the midpoint. Okay, I've got one more thing I want to show you before you leave. It's something on your homework you don't have to do. So if you look at your homework for today, there's 2 pages, there's some drawing, there's some just identifying, and then there's some actual math. But there's a column right here that says name the point of concurrency. We never talked about the word concurrency today, so I don't want you to do that. You don't know how to do that yet. So just put a big X through that when you get on your worksheet later, okay? I'm gonna stop my share. I'm gonna stop my record. I'm